All right, so let's get going on this first intro class. So what we're going to be doing today is your introduction to statistical analysis and psychology. So this will be our time where I'm going to introduce who I am. So I see some familiar faces, others I'm seeing for the first time. So I'll just give you a brief introduction. How do you say my last name? Some of the research projects that I'm working on that I actually do use statistics for. And then just a little bit about the Stigma-Free Initiative that I'm a part of. After that, we'll go through the course overview, course procedure, and then we'll hit the syllabus highlights. And basically, this is just an intro to the course to make sure that everybody is on board, knows what's expected, and can navigate through the rest of this semester. All right, so let's start off with who I am. So first, the hardest part of this course, pronouncing my last name. So my name is Dr. Igor Yurichevich. So we're going to break that down into component parts. So it starts off with a U, and then that's followed by a reach. And then you open up and say, and then finally there's a veach. And that little triangle gray section right there, that's what's known as a veach. So it's U, reach, veach. So let's give that a try on 3. 1, 2, 3. All right, not bad, pretty good. All right, so very important slide, especially in this course, because in statistics, it's not an intuitive way of thinking. It's going to be new to everybody here, and you're going to have a lot of questions. So if at any time something isn't making sense, refer to this slide, put the hand up, and say, Dr. Yurichevich, can I see that one more time? Dr. Yurichevich, my Excel has just crashed. I don't know what to do. Dr. Yurichevich, what do you mean by a z-score? Anything like that. Statistics is very challenging, but definitely something that's very doable. But one of the big things to keep in mind is that you have to stay on course when you're doing statistics. So whatever you need, put the hand up. Dr. Yurichevich, I just need this to help me stay on course in today's class. Definitely do that. Refer back to the slide, and we will have plenty of time built into every class to answer any questions or address any of those concerns. So who am I in terms of the research projects that I do here at IUSB? Some of the research projects that I actually use the very statistics that you're going to learn about in this course in order to accomplish. Well, currently my major focus is on studying visual language. So visual language is the visual version of the ways that we communicate. So we have auditory language, we have written language, and more importantly in our society, we have visual language. So especially with the advent of social media, people are communicating much more in a visual manner. So my research is currently focused on how do we understand pictures, how do we understand this visual information and process it so we understand what an artist might be communicating. A large portion of my research deals with a specific form of art and visual language communication, which is comic book art. So comic book art has to take a lot of information and communicate it in a visual manner that is understandable by a wide range of individuals, making it perfect to understand, to analyze, to understand our own, the average person's way of understanding visual information. So some of the things that I do in my lab is we'll take a look, me and my research assistants, we'll take a look at the art that has been produced, and we look for commonalities. We're basically looking for visual grammar. So for example, here are 2 pictures by 2 different artists, and you'll notice that there are similarities between these 2 pictures. Basically, they're using the same visual grammar. So in both cases, the villain has been drawn as a large figure on the picture. Neither of these villains are gigantic in size, but in both cases, they've been drawn using these large figures. And that's a metaphor. That's visual language telling the viewer that these individuals are important, that they're powerful, that they're dangerous. This is all communicated by using that gigantic size grammar. Another thing that's similar between these two is the placement of the hero. So that hero, Daredevil, and Falcon there, they could have been placed right in the middle of the page. The artist could have easily drawn them right in the middle, but the artist decided to put them asymmetrical in the picture. And this asymmetry is another communication. It's another aspect of visual language. And what asymmetry tells us is that the person or the thing that's asymmetrical is not completely regular or natural or typical. So most things in the natural world have symmetry to them, right? Humans themselves have bilateral symmetry. We have a right side and a left side, and they're pretty much the same. So anything that's asymmetrical kind of triggers in our minds these feelings of, oh, this is something different. This is something apart from me, something special. And that's what they'll use to communicate the idea that Daredevil and Falcon might look like us, but they've got extra things that are special about them. Other research that we've looked at in my lab is the perception of motion in a static image. So there is nothing moving in that picture there, and yet we all understand, oh, the Flash is running, he's in motion. So how do you understand that? And in this project, we specifically looked at how do you understand the literal communications in this picture. So when you run, your arms and legs will literally be in that position. So that's a literal device, that's literal information. But then there's also metaphorical information, things that don't happen in the real world, specifically these action lines, which no matter how fast you run, you're never going to have lines coming out the back of you. So how does a person looking at this understand that some of this information needs to be taken literally and some of it needs to be taken metaphorically, and then how is that combined? So that's one of the projects that I was doing with a graduate of IUSB back when she was here as an undergraduate, and we actually published this in the Comics Grid, the Journal of Comics Scholarship, about how our minds process those different sources of information, literal and metaphorical. And I published another follow-up study, again, testing that same sort of idea. In just a week and a half, I'm going to be at a conference in Toronto talking about some of this research. And one of the projects that we're going to present is the project that took a look at how do we determine whether information is metaphorical or is the information literal. So whenever you have a metaphor, whether it's in language, whether it's visual, one of the challenges for the listener is to determine, are you being metaphorical or are you being literal? So if you say something like, oh, John has a heart of stone, you have to decide as a listener, does John have a granite heart that needs immediate medical attention? Or are you trying to say metaphorically, John's cold, he's emotionless, he's ruthless? So we make those determinations in language, and we also make those determinations in visual language. So this is an example of the the pictorial device of gigantic size. So this is Mockingbird over here, and she is a regular-sized human being, but the artist has depicted her as this gigantic woman, and this use of gigantic size is metaphorical. This is not about her being a giant. This is a story about her, and they're emphasizing or communicating that she's important, she's powerful, she's going to be central to the story. These are all things that gigantic size metaphor is communicating. On the other hand, sometimes you have literal giants. So Galactus is a character in Marvel Comics who is literally like larger than a skyscraper. So in this case, gigantic size for Galactus is to be understood literally. So we did a study where we took a look at how do viewers make that decision? How do they decide whether something is to be understood as metaphorical or whether that same image, that same type of image is to be understood literally? And that led to some really interesting results that we published also with an undergrad student at the International Journal of Comic Art, and basically showed how we make those determinations between literal and metaphorical information. All right, and one last little one, just to kind of know the kind of things that we use statistics for, and just some of the things that I'm doing in my research lab. Metaphors have to come from somewhere. Somebody was the first person that ever said life is a journey. right? That had to come from somewhere. And then other people said, that makes a lot of sense. I'm going to use that. And it kind of spread through our language. Same thing with visual metaphors. We have some metaphors that everybody knows, everybody understands. So the light bulb indicating a good idea. That's a metaphor that has made its ways and incorporated into our collected visual language. But where did it come from? And how did it move through our visual language? That's what my last study that I'll mention looked at. So I didn't study the light bulb on top of the head. I studied another metaphor. So I identified a metaphor that was being used, which I termed close-up eye asymmetry. And this is the metaphor where you present a person in a close-up view, and then you make their eyes asymmetrical. Something about their eyes is asymmetrical. And this, again, communicates the idea that they're different from us. They're accessible because they're close up, but they're alien because they're asymmetrical, or they're different because they're asymmetrical. So, for example, here with Storm, we got the lightning only coming out of one eye. That's not an aspect of her powers. Neither is it an aspect of Magneto's powers, or in the Harbinger comics, it's not an aspect of his power. So you have that type of eye asymmetry. You can also do it through shading, or the Rocketeer over here, or the placement of objects. So the Joker holding a camera. That's one of those, this is before they had phones attached to them, but a Joker holding a camera, or, you know, this individual holding a skull. Could put the skull anywhere. The artist could have had it centered, the artist could have had it over his head, down over here, but the artist wanted to communicate using that metaphor, so he used that eye asymmetry. And then you can also just do it with different aspects of composition. So again, we've seen this grammar used before. And once again, we have it covering only one eye, covering only one eye, covering only one eye, not centered. So this has been used in static comic book art. It's also been adapted and been used in the screen. So if you've seen Deadpool 2, Cable is sort of the poster boy for close-up eye asymmetry. He's got asymmetry on both eyes, scars on the one side, light-up eye on the other. And I traced the development of this metaphor and the use of this metaphor, and surprisingly, I was able to trace it back to a single crystallizing event. So if you take a look at studies on artistic development, oftentimes they've identified these crystallizing events, and these are events important exposures to art that occur in and around this very sensitive period of about 9 to 12 years old. So when you're developing artists, when you're a child and you're around 9 to 12 years old, you're very impressionable. You got the skills that are required in order to make art and start making art, but you're still very impressionable. It's that critical period where a certain event, a certain image can have a profound influence on you, and you take a look at that and you say, wow, I want my art to look like that, or I want to do that, or this is something that I want to emulate. And I traced this close-up eye asymmetry back to an image that David Bowie had for his 1974 album, Aladdin Sane. Now, this is not the first time that this eye asymmetry was used in art. This is not the first time that somebody had something on one side of their face but not on the other side of their face. But if you were a kid, 9 to 12 years old, in 1974, this was an important album. It was a very popular album. This image was everywhere. You may have been exposed to it. And then these same children, when they were 9 to 12 in 1974, they came into their peak artistic period in and around their 30s. So if you take a look at artists, they tend to be most prolific, most creative in about their 30s. And in their 30s, these artists were basically, it was the 90s, and they just started using eye asymmetry everywhere. All their characters were designed with it. All their images were compositions used it. It was a very influential thing, and it was all could be traced back to this one image. So that was a crystallizing event that led to the spread of this metaphor through our visual language. This was also, I published this one in the Comics Grid, Journal of Comics Scholarship. This is also something I'll be presenting at the conference that's coming up in about a week and a half in Toronto. And I'm quite proud of this one because to my knowledge, this is the first time this analysis has been done where you could trace back a metaphor, a visual metaphor, not to the first time that it was used, but that important time when it influenced a bunch of creators who then later incorporated it into our language. All right, so that's just a snapshot of some of the research that I've been doing here at IUSB, research that I use against statistics to make decisions about, to analyze. So if you're interested or you want to check out some more, you can check out some of my posts on either Twitter or Instagram at @insane. Other things that are related to my research, I hashtag with Comic Book of Scientist. And if you want to see what some of my students have been up to, you can search for the hashtag Too Hard for Soft Science and see what they've been up to. All right, so that's the research. So last thing about me, we'll talk about the Stigma-Free Initiative. All right, so the National Alliance on Mental Illness, they have a stigma-free program where they're encouraging people to talk about mental illness, talk about mental disorders, to basically remove the stigma around having a mental disorder. So in our society, people are often unfairly judged, people are often unfairly treated if they have a mental disorder, and if they're not, that fear is definitely part of our culture, where people are worried, you know, if I come out and I say that I'm depressed, how are they going to treat me? If I come out and let them know that I'm struggling with this, you know, how's it going to go down? So this is an initiative asking people to be more open and honest about their mental disorders and in order to be stigma-free. So as part of this initiative, it's a very important part of the way I like to live. I just like to let all the students in my courses know that I battle with depression. I'm doing much better now, but haven't always been the case. But just to kind of let you know how devastating depression can be, and also the light on the other side of the tunnel. I started here at IUSB back in fall 2010. I was formally diagnosed with depression in the spring of 2012. That does not mean that that's when my depression started. Because of the stigma that's attached to mental illnesses, I was actually living undiagnosed and just struggling through on my own for I don't know how many years. So definitely, you know, if there wasn't a stigma, I don't know anybody who breaks their arm and spends 2 years going, no, it's fine, man, I can totally get by with a broken arm. But people will suffer through depression, suffer through other mental disorders, and be like, no, I can handle this, it's fine. And again, it's because of that stigma that's attached. I had both prescriptions and cognitive behavioral therapy that I underwent. In spring of 2013, I filled my last prescription. I would love to say that I was cured and that was it. But recovery is an ongoing process. There's good days, there's bad days. Number of bad days are going down, number of good days are going up. But it's still a journey. But just to kind of show you the impact that it can have, there's one of the ways that people, universities, scientists measure productivity is with publications. So how many papers have you published this year? That's often a measure of productivity. And when I was battling with the depression, when it was at its worst, I managed to squeeze out one publication back in 2012. That's not a lot. But after the cognitive behavioral therapy and after, just practicing and working and getting better, in spring of 2016, I published 2 articles. And then later that year, I published a 3rd article. And then in 2017, I published 5 articles. So this is the light at the end of the tunnel. So for anybody that's currently maybe going through depression or any other mental illness, just know that there is light at the end of the tunnel. Things can be done. Things can get turned around. And there's no reason whatsoever to be living in this part of it without, getting the help that you need. So as a sort of final PSA, I would like to encourage anyone who thinks that they might have a mental illness, thinks that they might be suffering from depression, for example, or if you know a friend that thinks that they might be, or you think that they might be suffering from this mental illness, go get some help, talk to a doctor, talk to your doctor. If you don't know where to start, come see me, because I had no idea. I thought that I was, I was just having some bad days. I thought that I just needed to be more energetic, or just push through this, just, stiff upper lip, let's do this. And that's a myth. You cannot do this alone. I thought that maybe I could handle this on my own. You can't. It's impossible. It's a myth that you can handle this alone. So you need to get help. You need to get your team together. So if you think that you might be suffering from a mental illness, or if you have a friend who thinks that they might be suffering from a mental illness, say something, go get help, go ask, go talk to somebody. And if you don't know where to start, come talk to me. I've been through it, so, feel free to do that. All right, enough about me. Course time. Okay, so course overview. What we're going to be doing is this is going to be your introduction to statistics and probabilities, mostly statistics, with an emphasis on psychology research. So if we still had the physical textbook, and this was a statistics course. So if you were in here and this was the introduction to statistics for statisticians, your textbook would probably be about that thick. If it's an introduction to statistics for the life sciences, it squeezes down to about that much. If it's an introduction to statistics for psychology, it squeezes down a little bit more. So we're going to focus on just the things that psychologists use most often to either analyze their research, or when you read other people's research, we're going to focus on the tests that are used most in the psychology discipline. So reviews, concepts that we'll review: measures of central tendency and dispersion, variability, statistical inference, decision-making, hypothesis testing, analysis of variance. You probably will not know what any of those mean right now. You will by the end of this course. The other thing that we'll emphasize is you're going to develop competence and skills in using current software. So we're going to be using Excel at the beginning of this course, and then in the second half, we're going to switch over to SPSS, and that's a requirement of the course, so you'll learn the skills that you need in order to use that software, so that we're not in the Stone Age doing, pencil and paper calculations. All right, objectives. We're going to be using formulas in Excel to calculate stats. We're going to be using My Stat Lab, or My Math Lab, or My Lab, whatever it is that it's called, to complete your pre-test, post-test, and homework. We'll be looking at how to make frequency distributions and interpret them, how to measure the central tendency, variability, how to interpret z-scores, how to choose the correct hypothesis test for a wide variety of experimental designs that are used specifically in psychology, and then also how to use SPSS to do all these tests. So to kind of set the stage for why we're going to be doing all this, let's say that you were working in a clinic and you were doing work with people who are suffering from depression. And you had two groups of people, and you had two new treatments, right? You just heard about two new treatments, treatment A and treatment B, and you wanted to know which one of these is better, which one of these is the better treatment. So you take group one and you give them treatment A, you take group two, you give them treatment B, and then you measure their level of depression. You give them the Beck's Depression Inventory. And let's say that first group had a Beck's Depression Inventory score of 42.6. That was the average score. Average score for the second group was 25.7. We know that 25.7 is a lower score, right? We know that. We can look at that. This is not what we're going to be learning in this course. Hopefully you already know. 25.7, less than 42.6. But the question is, why is it less than 42.6? And there's two possible answers. Possible answer number one is the obvious answer. This is the better treatment. The score is lower because it's better. That's possibility number one. Possibility number two is that this treatment is not any better, but you just got lucky, right? The sample that you had was just a sample that had lower depression. That day that you took this, they gave them this test, they just happened to have, lower depression that day. That's possibility two. So possibility one is that the treatment works. Possibility two is that the treatment does not work. And what we're going to do in this course is we're going to learn how to determine between those two possibilities. Because this is essentially, especially important in psychology, because if you make a mistake on either of those, you're going to be impacting lives very, very fundamentally. So let's say that this did work, and you say, yes, this does work. You call the clinics, you put everybody on treatment B. That's wonderful. But if this doesn't work, and you call other clinics and you put these patients on treatment B, you're putting them on a treatment that doesn't work any better than treatment A. You're putting them on a treatment that has no difference, and that's a mistake because it might be a worse off treatment than if they were on something else. On the other hand, if treatment A does do something, and you look at this data and you say, you know what, I don't know if if treatment B does do something, if it is more effective, but you miss that, you make the decision that it's the same as treatment A, then you're not affording this wonderful treatment to people that really need it. So as psychologists, the reason that we do statistics is because in our minds it's very easy, 25.7 lower than 42.6, but stats is going to tell us why. Was it because this treatment is really better, or is this just a fluke occurrence and we shouldn't move forward with any changes to treatment? So why was treatment B better? Was it a real difference or was it a fluke result? That's what, in essence, we're going to be learning in this course, to tell the difference between the real difference and the fluke result. All right, a little bit more course overview. I'm going to give you the briefest discussion of stats history you're ever going to see, and let's get going. So, Francis Galton. You won't have to know any of this, so just kind of sit back and relax. But anyways, Francis Galton, he's kind of the godfather of statistics. A lot of the basic calculations, basic ideas in statistics, he's the one that came up with them. The average, the measure of central tendency, he's the one that came up with that. William Gossett, he came up with the t-test, and he's one of the few statisticians that did not name his test after himself because he wanted to stay anonymous. He actually called it the student's t-test initially. This is one of the ones that we're going to find. This is one of the first hypothesis tests that we're going to use. So William Gossett made that possible. Ronald Fisher came up with the F-test. That's used for ANOVAs. F for Fisher. John Wilder Tukey. I just love that his name is almost Wilder Turkey. But John Wilder Tukey came up with the Tukey test, which is also used in ANOVAs. So you can see that they're usually kind of not very creative in their naming. So he came up with the Tukey test that we'll also encounter near the end of the semester. So those are four very important statisticians whose work we're going to encounter in this semester. There are also important mathematicians. So Euclid came up with Euclid's geometry, basically the natural way your mind thinks of the world. Euclid came up with that geometry, way back in ancient times. Pythagoras, hopefully everybody remembers the Pythagorean theorem. The sum of the squares of two sides of a triangle equals the sum of the square of the hypotenuse, equals the square of the hypotenuse. Pythagoras came up with that. Isaac Newton invented calculus. That was one of his big contributions to mathematics. And then I thought one of the latest ones that made a huge contribution was Kurt Gödel. And Gödel came up with this idea. One of his big contributions was the idea of the incompleteness theorem, which is to say that the more complicated a system becomes, and he actually proved this, the more complicated a system becomes, the less it's able to be complete, which is kind of counterintuitive, but it'll always be incomplete. And this is actually, his work is kind of being now incorporated into studies of consciousness because of his sort of self-referential theories and stuff. If you ever want an easily accessible book, and by easily accessible, I don't mean thin, I mean kind of straightforward. Gödel, Escher, and Bach, The Eternal Golden Braid, is written really well. If you're interested in consciousness or those sort of really higher order psychology questions, is also a great read by Hofstadter. And just to kind of show you how influential this book is. If you ever kind of like stalk a mathematician's Instagram feed, this is what their selfies look like, because this book was just so easily accessible and put it out there in a very interesting way. Anyways, that's Gödel and the incompleteness theorem. So why am I giving you this brief history of stats and brief history of math? Well, it's to prove a very important point. So up there we got all the great statisticians that contributed to what we're going to be learning in this course. Down here we have a bunch of great mathematicians that contributed wonderful things to mathematics. And importantly, none of those are in the top and bottom. So the guys in the top are statisticians, the guys in the bottom are mathematicians, and there is no crossover here. So I put this up because one of the things that I think students worry about the most for this course is that they're not great mathematicians. So a lot of the students that come to my advising sessions, they'll say, oh, I got to take stats, but I'm not good at math. I've never been good at math. I don't have that math mind. I've always struggled with math. And I'm here to tell you that it doesn't matter. Math is not statistics. The math that you're going to use in statistics, you've learned it, you know it. I'm not going to teach you any new math. I'm going to teach you, that's a lie, I'll teach you 2 new things next class, and that's it for the new math. But just want to drive this home, this is not a math class. This is applying very simple mathematics and mathematical ideas to analyze psychology questions. And like I said, you'll learn 2 new things in math. Next class, that's it. So if you were coming in here worried about your math skills, don't be. Push that out of your mind. Get that out of your narrative, because it's not math. It's statistics. So you'll learn statistics in this course. And like I said, 2 pieces of math. All right, so what else is going to happen in this course? Well, this course, like many of my courses, but this one especially, is going to change the way that you think. So you are going to learn how to think like a statistician in this course. You're going to learn how to kind of take a look at a bunch of data and say, I know how to analyze this data. I know what to do with this. So you're going to learn to think like a statistician. You're going to learn to be like Ronald Fisher there. But the one thing that you need to keep in mind is that statistical thinking in your entire psychology major experience, statistical thinking is the one type of thinking that needs to be practiced and practiced and practiced. It's not something that you can just read and understand and then be able to do. You actually have to put the boots on the ground and do the stats. So it absolutely needs to be practiced. And that's good news, because I'm going to assume that everybody starts at the beginning. I'm going to assume that nobody here peruses Wikipedia pages about statistics in their free time, I'm guessing, right? I'm going to assume that nobody in here, came with an understanding of stats. So everybody's starting at the beginning, and get rid of the idea that you're not going to be able to do statistics, because everyone can do this. I have had students who are A+ math students. I've had students that barely scraped by in Math 111, and both of them turned into A+ students by the end of this course. This is something that everybody can do. I put together a program that will bring everybody along with doable steps. So just know that, trust the program, follow along in class, but definitely practice. So again, it doesn't matter if you're an A+ math student. It doesn't matter if you barely passed your prerequisites. If you do not practice, this course will be disastrous. If you do practice, you'll make it to the end. You'll understand everything. You'll get yourself an A+, and you'll have a great experience. So let's talk a little bit more about that need for practice. So that's a clock there, and if you don't know what those numbers are, that's fine. This ain't a math course, but this is just that's 1, 2, 3, 4 on that dial. So the way that I'm going to try to do most lectures, not all of them, but most of them, I'm going to try to have approximately half of the class be a lecture, like today, right? So just like I'm talking to you, I'm going to explain some stuff. We're going to take a look at a few examples. So about half of it's going to be lecture. And then the other half is going to be dedicated to practice. So I'm going to try to have like half an hour where I'm just like this is what we learned today. Here are some practice problems. Go ahead, try them out. And this is your time to try out the new things that we've been talking about, to actually practice them with me kind of wandering around. And if you need help, refer to that slide, Dr. Yudishevich. I'm stuck. Can you help me out here? And we'll make sure that everybody, gets that practice in. So I'll try to do that as much as I can. And I really, again, want to drive home this idea of the need for practice. So I found this one nice little demonstration that kind of hits home to me. I'm like the comic book guy around here. So this is a nice little demonstration of how much you want to practice and how much you want to kind of put into making sure that you get things right. So it's a brief video. Part of it is a little bit crude, but I think it drives this point home.
Batman. I'm Batman. Fire! It's time to see more of my responsibilities, boss. Batman. I'm Batman. I am Batman. I want you to tell your friends there's a new face of justice in Gotham. Who are you? I'm Bruce Wayne.
All right. So you do not want that to be you. All right. So one of the sayings that I like is, don't practice until you can get it right. Practice it until you can't get it wrong. So when you do something, for example, a z-score. Z-scores are often one of the first concepts in here that, in this course that students will find a hurdle in order to jump over. So you'll practice the z-scores and you'll try them over and you'll try them over and you'll try them over. And finally, you'll calculate that z-score. That's not the end of it. It's not when you can finally get it right. What you want to do is you want to practice it again and try it again and try it again until you get to the point where you sit down to a z-score and it's just automatic. You just know what to do. You've done it so many times that you now cannot get it wrong, because you do not want to be that student that opens up their exam and question number one is, who are you? And you're like, I'm Bruce Wayne. And it's happened, right? It's happened to everybody where you get to the exam and you're like, I thought I knew this, but I don't. So just bear that in mind as we're going through this course. You'll have plenty of opportunity for practice. Take advantage of all of it. Do as much as you can so that we can get these skills just kind of automatic in our minds. So the course, continuing with the course overview, I'll give you a sort of visual demonstration of what's going to happen this semester. So that's you right now. This is the information that you currently have about statistics. So you do know some things, such as calculating an average, what numbers are, all those kind of good things. And then you have certain skills. You might know how to use Excel a little bit. You might know how to do certain calculations. So you have some knowledge. You have some skills. That's where you're starting today. This is where we're going to end up by the end of the semester. Now, as you'll notice, there is no way for you here to get to here today. So if I gave you the final exam right now and I said, do it, you would be like, no, I can't. So, but we're going to get you there. That's what this course is all about. So what we're going to do is we're going to increase your knowledge step by step, bit by bit, until you can finally reach that final summit. And you'll notice that in the first week or so, the skills that you currently have, this stick that you currently have representing your skills, it's enough to get you to that next summit, right? So the skills that you have will be enough to get you to that next summit. But then what you'll find is that the skills that you currently have will just not be good enough anymore. And that's where the practice comes in. That's where increasing those skills, getting better at Excel, getting better at calculating these formulas will help you. And we're going to continue to do that, continue to increase the knowledge that we're trying to get to, continue to increase the skills that we have until finally we can get all the way up to that final summit, all the way up to your final exam, and you'll be happy and wondering why you ever might have been intimidated about doing statistics in the first place. So that's going to be the end result with you up there, if you continue to practice throughout the semester. So if you don't practice and you try to get from one topic to the next topic, this is going to happen to you, and you're going to find yourself at the bottom of a dark and desolate pit. So this has happened to many a student. If this happens to you, well, number one, try to not let this happen to you. Number two, if this happens to you, if you're ever in a lecture and you get to the end of that lecture and you say to yourself, I have no idea what he talked about. I have no idea what he was talking about today. Or you get an exam back and you just tanked on the exam and you're looking at it going, I thought I knew it. And either of those means that you're in this dark little pit over here. I have rescued students from this pit many, many times. So it's not the end of the world, but definitely if that ever happens to you, come to an office hour, come see me, say you were doing Z-scores, I thought I knew it, but then I did exam number one and oh my goodness, I got 0 on that question. I still don't know what I'm doing wrong. And we'll make sure that you get back on track. So do this immediately though. Right? Maybe give yourself one day to go back and review to see if maybe you missed something. But if it's not making sense by the next class, at the latest, come and see me. Let's get that hammered out, because your opportunities to come back in this course start getting eaten up as the weeks go by, and you don't want to leave it off too long. And this is especially important in this course because while the exams will not be cumulative, the course is cumulative. So there will never be a topic that we learn that is not going to be used in the next week. So for example, the first thing that we're going to learn is about summation. Summation is then used to calculate averages. Averages are then used to calculate standard deviations. Averages and standard deviations are then used to calculate z-scores. It all builds. So in no way, shape, or form can you ever say to yourself, well, I kind of know averages. I'm really struggling with standard deviations. That's fine. I'll just wing it. You won't. You'll wing yourself down here, and you'll wonder, what's going on. So, again, if you ever get an exam back and you didn't do well, if you ever get 0 on a homework assignment, or you miss, some questions completely, and you don't know why, or if it's ever the end of a lecture and you're sitting in the lecture going, what was he talking about? I have no idea. You're down here. Come see me. We can fix it and we can get you back on track. All right, any questions so far about anything? All right, cool. Course procedure. I like to run all my courses like a research lab meeting. That means that all concepts are open to ideas and discussion. Just kind of raise your hand and let us know what you're thinking. Let us know if you have any questions. I am a firm believer that there are no bad questions or bad ideas. Everybody knows the phrase, there's no bad question except the one that's not asked. And that's true, but there are wrong ideas. And you're probably going to have a lot of wrong ideas. And statistics is not something that people develop on their own. If you just let a child roam free in the forest, they'll never come back and say, hey, you know what? I've learned how to calculate an average. It just doesn't happen. So you're going to have wrong ideas. You're going to have false starts. But I'm here to tell you that even if the majority of what you're thinking is wrong, that's what this course is about, is to get you on the right track, to correct your thinking, to make sure that by the end of it, you can do statistics. And honestly, you might have a ton of wrong ideas, but that's just how science works. So I am very empathizing with students that don't get it right the first time, because that's literally my entire career. Every experiment that I do, I got about a 95% chance that it's not going to produce the results that I thought. And that's why you do the experiment. So I understand it. So don't feel intimidated. Don't feel, don't feel bad about maybe not understanding something right off the bat. Especially if you see your fellow students, if you look over and they're all like, yeah, big smiles on their face, and you're like, oh my gosh, I don't get this. Raise that hand, call me over, and we'll make sure that you're on the correct path. All right, some syllabus stuff. Contacting Canvas. My office is upstairs in this building, 2163. Office hours right before this class and right after this class. So I might have to change that first office hour. I booked it right up to 2:30, which is when this class starts. So if I find myself coming to this class like 5 minutes late, I'll move it a little bit, but hopefully not, because I do like that same day office hours for a class. There's a phone number for my office. Please don't use it. It's honestly right now it's not even plugged into my computer. But if you do need to get in contact with me, use Canvas messages. Do not use my official IUSB email address. I check that maybe 2 days a week. Canvas messages, I commit to checking every 24 hours. So way quicker turnaround on Canvas messages. Keeps everything nice and organized. So if you do need anything outside of office hours or class hours, Canvas messages, and I'll try to get a 24-hour turnaround on that. And speaking of Canvas, that's where you can stay up to date on the courses. You're going to have lecture slides. So for example, all these slides are available to you. You might already have seen them on Canvas. Course information, the syllabus, grades, all of that stuff we're doing through Canvas. In terms of the required text, this course is part of the eText initiative here at IUSB. So you should already have access to the textbook. We're going to be using MyLab for homework, for quizzes. You have an e-text in there. So if you haven't already, go to Canvas, today, check it out. Make sure that you can get in there. Make sure that you can see some of the assignments. You should get to this point here where you can see a view of MyLab here, where basically it has your schedule, a little bit more of your schedule, browser checks and all that. So I would highly recommend get in there, start poking around, start looking at things, and start trying out different stuff. Especially make sure that it works on your main computer. So sometimes MyLab, I found it very fickle with certain browsers. Sometimes you need to install like the latest version of Java or something. So I would highly recommend whatever computer you're going to use to do most of your work on tonight, just check it out, make sure that you can access it, make sure that the textbook opens up, and just make sure everything is up and running. Other resources. Here at IUSB, you'll have access to both Excel and SPSS, and you'll have access to those for free. So SPSS is accessible through all these machines. Excel is installed on computers here at the university. So that's great when you're here at IUSB. When you're at home, you can get, if you already don't have Excel, I highly recommend go to IUware, and you can get a copy of Office and download it here as students. So the subscription, the product key is paid for as students, so you can get that and download that for free. And you can have free access to SPSS through the IU Anywhere program. So I want to be very clear about this. You're going to need SPSS in order to do work in this course in the second half. You can download SPSS and install it on your computer, but you will then have to pay a subscription fee if you install it on your computer. However, you can use IU Anywhere, and as long as you have an internet connection and you install the program, the small little Citrix receiver program, you can use SPSS from your home for free with no subscription, because you're not installing it on your computer. We paid for the rights to allow you to stream the program, but you can't install it on your computer. So I just want to make sure that nobody installs it on their computer and feels that they have to pay that subscription fee. So again, you can go to one IU, you can go to IU Anywhere, find SPSS, and it'll be able to run for free on your computer at home. All right, other information, performance evaluations. So I am a firm believer in pretests because the statistics indicates that pretests are a very effective way of increasing learning outcomes, especially on come exam time. So a pretest is where you read the material on your own, you go through a test before we've covered it in class. So there's going to be 8 pretests. They're due by the due dates listed, and I'll show you those in the class schedule. They're going to be short tests that are covering the assigned readings. So I expect you to complete the readings before you come to class. As you're reading through them, feel free to do these pretests. They just basically kind of get you ready for class that day. And I just want to note that pretests, because they're designed to prepare you for class, they cannot be completed after the due dates. All of the assignments, all of the pretests, all of the post-tests, they're already available. So if you want to blow through them in 3 weeks, feel free. But after the due dates, you cannot access the pretests any longer. So these pretests are designed to get you ready for class. And I will admit, some of the pretests might be very challenging. So statistical concepts, they are challenging. Studies have been shown, though, that just struggling with the pretest, just trying it, just going through it, making mistakes, maybe getting questions wrong, but just exposing yourself to that material and giving it a go will pay huge dividends later on in your exams. So I keep pretests on for that reason. But because statistical pretests can be very challenging at times, I don't want to tank anybody's grade. So if you do not get 100% on your pretest, for any pretest that you do, you can make up that grade using the study plan mastery points. So when you become more familiar with MyStatLab, and one of your first assignments is just, here's a video, watch it in MyStatLab, you'll find the study mastery points. These are places where you can relearn the material, quizzes that you can do 4 points. So if you complete the Quiz Me quizzes in the study plan by the due dates, you can earn up to 100% of your pretest grade. So if you get 50% on your pretest, but you finish 100% of the study mastery points, you will be awarded 100% for that pretest. So everybody can end up with 100% on their pretest for sure using this system. So you'll get the benefits of the pretest, but it won't impact your grade negatively if you find the pretests especially challenging. So just one little caveat about that. While the Quiz Me quizzes can be completed after the due dates, the mastery points can only be earned up to the due dates that are listed. So again, if you want to earn that 100%, you're invited to complete these, and they need to be completed by the due dates listed in the class schedule. Post-tests. We will also have post-tests. So we have pre-tests and we have post-tests. And the post-tests are, again, going to be a post-test. They're basically like the pre-tests, new sets of questions, but they also need to be completed by the due dates. So this is all part of the sort of commitment to practice that we're going to have in this course. So if you take a look at how much exposure you're going to have to the ideas and the concepts here, you're going to do your pre-test. So you're going to read the information, and then you're actually going to go in and crunch some numbers, do some statistics for your pre-test. So that's practice number 1. Then we're going to be doing some practice in class, right? That's opportunity number 2 for practice. Then you're going to be doing the homework. That's opportunity number 3. Then you're going to be doing the post-test. That's opportunity number 4. So you're going to have 4 shots minimum at every one of these concepts in order to practice them before we go to the exams. So pre-test, post-test, homework, make sure that you're doing them all. In-class practice, make sure that you're doing that as well so that you're prepared for the exams. So the exams, if you want to earn 40% towards your final grade, you're invited to complete the 4 exams, 3 exams plus 1 final exam. non-cumulative, so it's only on this, it's really just exam 1, 2, 3, and 4. However, as I said, this entire course is cumulative. So once more, do not think that you can let a concept pass you by. Make sure that you're getting on top of everything, because everything in exam 1 we will be using in exam 4. We just won't be specifically asking you about that. And because this course is not about memorization, it's not about committing formulas to memory or going through long lists and getting every single plus or minus right. The exams are going to be open book. So the pre-tests, have your book right next to you. The homework, have your book right next to you. The post-test, have your book right next to you. The exams, have your book right next to you. In fact, have any materials that you need in order to complete the exam. So the exams are basically open materials. So if you want to have your textbook open on screen, that's fine. You want to have notes that you took to help you, that's fine. You want to go online and look up a Wikipedia article about F-tests, that's fine. It's allowed. It's not a good idea, and I'll tell you why in a second. But they're open book. They're open to anything, because this is not about memorization. This is about knowing what to do. So that's the way that the real world is, and I kind of modeled this course after the expectations that people have in the real world. So if somebody came to me and said, hey, I have all this data, can you do this statistical test? And I look at it and I say, honestly, sometimes I'm like, wow, I haven't done that statistical test in ages. Let me go to YouTube and see what they say on how it is to be done. So I look up things on how to do certain statistics that I haven't seen in forever, and nobody judges me for it. So it's going to be open book. You can look stuff up. You don't have to memorize anything for this course. However, I will say this, do not learn the material during the exam. So if you're using the open book and you're sitting there and you're like, oh man, I got to calculate a z-score. What was the formula for the z-score? All right, let me check my textbook. Oh, there it is. That's what the open book is meant to be used for. It's meant so that you don't have to memorize things, you can understand things. But if you're at the exam going, oh my goodness, I have to calculate a z-score. What is a z-score? Maybe I'll read about it. Chapter 2, z-scores, and you're toast during the exam. So it's not your opportunity. It's not there for you to learn during the exam, because you will never finish the exam if you do. It's there so that you don't have to memorize everything, so you can offload all that cognitive resources that you might have used to memorize these things and use those instead to understand the stats and understand what it is that you need to do. And yeah, so take advantage of that. Again, whatever materials you want, your own notes, step-by-step guides, whatever, feel free to bring that to exams. Makeup exams. So if you miss an exam, you can write a makeup exam. If you miss the exam for circumstances that are beyond your control, so things that just, life that just sometimes happens to certain students. So you might come down with the flu. You might have a boss that is requiring you to go to a team building exercise and it just happens to be on the same day of the exam. You might wake up that morning and your daughter has a fever and you can't take her to daycare because they have a policy where it has to be 24 hours after the fever. Whatever it is, if circumstances beyond your control pop up, you can write the makeup exam. I'm very flexible on the circumstances that I will allow, but one thing that I absolutely have to insist on is that they're documented. So if you can't make it to the exam because you have the flu, go to the Health and Wellness Center, go to your doctor. I'll need some sort of doctor's note. I'll need some sort of documentation for that. If your boss is making you go to that team building exercise, forward me the email that they sent you. If your daycare does not allow you to bring your child in when they're sick, just ask them, look, email my professor. Please email my professor and just let him know that I was not able to bring my child in today. Just some sort of documentation that I must insist on it. So I'm very flexible for the circumstances. I've seen weird things happen that derailed students. But if it happens to you and you can't make an exam, absolutely get some documentation for it and you can write the makeup. And if you do need to write the makeup, the information, the steps that you need to take, you can find them in the syllabus. All right, homework assignments. We're going to have 14 homework assignments, and you can earn 28% towards your final grade by completing those. And again, those are going to be mostly through Canvas, mostly through my lab. So most of them are going to be through my lab. We're going to have 2 of them, though, that are Excel assignments that I've created myself, and those will be submitted through Canvas. I'll have more details on those as they come up. But most of what we're going to be doing here, the pre-test, the post-test, the homework, is going to be done through the MyLab website. And again, you can access that and log in through Canvas. And I highly recommend try it out tonight. Make sure that everything is working right. Homework assignments can be completed after the due date. So you can complete your homework assignments. If you've missed the due date, you can go back and finish them. But you will be given up 20% of the points for any uncompleted questions. So that's a nice thing. I mean, if you get 8 out of 10 questions done on the homework assignment and you get those, correct, you'll get full points for those 8 questions. And then if you want to go back, you'll be deducted 20% per day for those other 2 questions that you missed. So it's a nice way to hopefully kind of motivate everybody to finish their homework on time. But again, if you can't make it, if for some reason you weren't able to finish your homework, you can still go back and complete it. Just try to do that as soon as you can. All right, if you're unable to complete any tests or assignments due to circumstances that are beyond your control, let me know. I'll make sure that the missed work doesn't impact your final grade. So sometimes I can reopen an assignment. Sometimes I cannot. I'll let you know if I can or I cannot. But I don't want it to impact your final grade any way if it's beyond your control. But again, I must insist on documentation. So once again, if I had a student that had a relative that was ill and they had to be with them in the hospital for a week, that did not impact their final grade, but I do need that documentation. All right, a little bit more and we'll wrap up this first day. So there is the breakdown for the final grades, kind of standard stuff. But what might not be standard is where your points come from. So 8 pre-test, 16%, 8 post-test, 16%, 14 homework assignments, 28%. And then for those of you that have had my classes before, this will be familiar. For those of you that are new, I grade the exams on a sliding scale. What that means is that the exam that you perform the best at is going to be worth the most of your grade. The exam that you perform the worst at is going to be worth the least of your grade. So your best exam is going to be worth 16% of your final grade. Second best exam is 11. Third best exam is 8. And then your lowest exam is going to be only 5% of your final grade. So this is, I like to call this built-in forgiveness. And this is especially useful in statistics because some students, they're going to get statistics like that. So this week, maybe next week, they'll be like, oh, I totally get this. And everything will snap together and they'll bang out 100, 100, 100, 100 on all their exams. Other students, that snapping together might happen a little bit later, right? It might happen after the first exam. It might happen, after the second exam. So we can't just ignore the performance on exams. But if you're one of those students who after exam number 1, let's say that you get, 50% on exam number 1, just know that it's not the end of your statistics course. Because if you get 50% and that's your lowest exam, you're only losing 2.5% off your final grade. You can still get yourself an A+ in this course. So definitely, if that does happen, come see me and basically say, oh, I don't understand question number 2. Oh, I really did badly on question number 4. Come see me and we'll figure out why you did poorly on that exam. But just know that it's not the end of your grade here. It's not the end of your semester. And I have had students, and this course is why I instituted this policy. I've had students that struggled on the first exam and then struggled on the second exam. And then I don't know what it is. I don't know how to produce it, but it happens in every student. There comes a point where all of a sudden they're like, oh, I get it now. Oh my goodness, I understand it. And you almost can't imagine why it was difficult before. And exam 3 is 100%, exam 4 is 100%, homework after that is all 100%. So it happens to students at different times. So just know that if it happens to you, there's that built-in forgiveness with the exams. Also the built-in, study plan mastery points for the pre-tests. So there's a lot of ways to come back in this course. But again, do make sure that you address the situation as soon as possible. And if that means coming to me during an office hour, make sure that you're doing that. All right, electronic devices. While we're in the lab, you're all using a computer. This is more about cell phones. Feel free to have your cell phones out to record these lectures if you want to do that. But the one thing that I ask is that you not communicate using cell phones in the class. So if you do need to answer a text, if you do need to answer a phone call, I understand, some students, they got commitments outside. Maybe you got children in school and somebody's calling about your daughter. Feel free to just take your phone, stand up, walk outside of the class, deal with it. No questions. Don't worry about it. I completely understand. But please just don't do it in class as a courtesy to your other students. And then during the exams, just because it's very difficult to monitor cell phone use, we will not be allowing cell phones out during the exams. So I know that a lot of you might think to yourself, well, I like to use my calculator for some of these questions. We'll show you how to do that in Excel. You won't need the calculator for exams, so just bear that in mind. We won't be allowing them out during exams. All right, accommodations. So check the syllabus. It's available on campus. If you need any accommodations for religious observances, if you're a student with a disability, please let me know. We'll make sure that you get the accommodations that you need. And then also check the students for check the syllabus for information on student responsibilities, what we expect of you here at IUSB, what to do during a campus emergency, and the policy on sexual misconduct, so that we can have a safe and welcoming semester. All right, last thing I want to do is just hit some of the syllabus highlights so that you know how to navigate the syllabus. So, there we go. All right, so again, this syllabus is available right now on Canvas. And the due dates are reproduced in the MyLab as well. But just to kind of let you know how to read this. So you got your date, you got your topic for the day, and then the readings that are required. So for these first two dates, I'm not requiring any readings to be done. And next class, we're going to do our introduction to statistics. So the first thing you'll see here is that there's this new homework topics covered. I like making all the homework assignments available right from the beginning of the course. So if you do like working ahead, feel free to work ahead. If you do know that you have a week that's coming up that you're going to be absolutely swamped with other work, feel free to schedule ahead and maybe do a pre-test before that, a post-test before that. But just so that you know when we're going to cover the topics that are required for that homework, that's what this new homework topics covered indicates. So next class, we're going to make sure that everybody's up and going on MyMathLab, and that's when we're going to cover the information you need for homework assignment number 1, the MyMathLab tutorial. So throughout here, you'll see, here we go. Homework topics will be covered, and then they'll be due at a later date. But just to kind of let you know when we'll be covering the stuff that you'll need for that particular homework assignment. Stuff that is due is going to be here in red. So for example, Chapter 1 pretest is due, as well as homework assignment number 1, the MyMathLab tutorial. That is due August 27th by midnight. So all my assignments are typically due midnight the day before class. And that's just a nice way to ensure that you're not completing it 5 minutes before class and missing class because of that. So that's a system that I found has worked pretty well. So red are the due dates or the due times. Black down here are when we're going to cover that information. August 30th, we're going to have an online class. So I'm going to be out of the country. I'm going to be up in Toronto at a conference. So I won't be able to be here on that Thursday. What I'm going to do is I'm going to record the lecture. I'm going to post that online so you have access to it so that we can continue moving forward. So I'll remind you a few more times because we will not be physically meeting that day, but I will have material for you to watch and follow along online. So I'll set that up and give you all the details. but that's an online class that we're going to have on the 30th. So that's the only one there. And then for the rest of the semester, again, you'll see certain things are due, new homework topics are covered, and it'll typically go pre-test. Where's that pre-test? Now let's go back here. The formula is going to typically be pre-test, followed by homework assignment, followed by post-test for that chapter, with other chapters overlapping with the homework and the post-test. So a lot of little moving parts. It's here in the syllabus. It's also in your My Math Lab. So make sure that you stay on top of those due dates. September 13th, we're going to have a review session. So before every exam, the class before every exam is going to be an open review session. I'll have more details about that. But it's basically going to be an hour and 15 minutes of me standing up here and saying, what do you guys need to see to make sure that you're ready for the upcoming exam? So prior to the exam, there's going to be the open review sessions. And before the exam, there's always going to be a little bit of weirdness with the post-test, because I want you to be able to complete the post-test early enough so that you have time to review it before the exam on the next session. So that's when you might see some of those little weird, due at this particular time, at 2:30 p.m. So be aware of those dates, and I'll point them out for the early exams. Exam number 1 in Chapter 1 and 2 will be on September 18th. Exams will be in class. They'll be done on the computer. We'll have more details about that. Open book, so make sure that your materials are set. And that's basically it. So pre-test, homework topics introduced, homework due, post-test due, homework assignments. And that is the way it's going to work until that, one more page, until that final exam. All right, so are there any questions before we wrap up today? All good? All right, so thanks for coming by, and that's it for today. And we will see you all next class, where you will learn your 2 new pieces of math information. So I'll see you all next time.